All right, proving triangles congruent by SSS and HL. All right, I think you can probably guess what SSS stands for. We'll get to it. Okay, real quickly review. Measure one and angle, and it measure two. Sorry, wow. Measure of angle one, measure of angle two. Tell which theorem you used. Well, angle one is going to be equal to 180 minus 126 because they are a linear pair. Okay? So that means it's going to equal 54 degrees. And then measure of angle 2 is going to be 54 degrees because they are corresponding angles. And consequently, on number 2 here, kind of going backwards, the measure of angle 2 is 131 because, once again, 131 and angle 2, they're both obtuse angles. They're corresponding angles. And then measure of angle 1 is going to be equal to 180 minus 131 because they are a linear pair. So it's going to be 49 degrees. All right, so as you probably assumed, SSS means side, side, side. So it's kind of a duh theorem because if all the sides match up and are congruent, then the triangles are congruent. One of the more obvious ones. All right, so what we are given here is that KL is congruent to NL, which is marked, okay, right here and right here. Then we are given KM is congruent to NM. We're given that right here and here. And we'll say we are given that. And then this side, LM, is congruent to itself by the reflexive property. And guess what? We're done. Triangle KLM is congruent to triangle NLM by SSS. And that's it. Hypotenuse leg. So right here, we've talked about before that we cannot do this. Okay, so there is no, if I have these two triangles, and I have this angle here, this angle here, this side and this side, and this side and this side. That does not work with SAS because that is ASS or SSA. Okay, and there is no ASS rule. But this HL is sort of like it. Because if we did this initially with our first method, we would go, oh, these match, and then this side matches, and this side matches. But wait, we don't have an ASS rule. But there is one exception. Notice up here, it was an obtuse triangle. In the case of a right angle, a right triangle, if the hypotenuse, okay, which is right here, and one of the legs, one of the two legs, doesn't matter which one, match, then we do have congruent triangles. Only if they are right triangles. That's it. So, what do we have here? We have a lot of stuff given to us. WY is congruent to XZ. WZ is perpendicular to ZY, and XY is perpendicular to ZY. All of this is given. Now, this is one of those ones where I personally, I do it myself, I get confused, and so I will separate this into two triangles. This is W, this is X, this is Z, This is y. This is z. And this is y. Okay? Now, wy and xz, which is the hypotenuse, well, we don't know that yet, but those are the same. Wz is perpendicular to xy, or zy, and xy is perpendicular to zy. So now we have this right here, okay, where we have a right angle and a hypotenuse. We just need a leg to be congruent. Now, like I said, I like to separate them, but it's important to notice that zy is the same on both. Okay, so it is, when I separate it, I got to remember that that was the same line. So we're going to start off with our classic zy is congruent to zy by the reflexive property. Okay, and now we technically need to say that wzy, so angle wzy and angle xyz are 90 degrees, well, or right angles. And that's just a definition of perpendicular lines. And now that we have right angles and we have a congruent side right here, and we have a leg right there, so we have the hypotenuse and the leg, we can say triangle WYZ is congruent to triangle XZY by HL. And it's only because it's a right triangle. Otherwise, we'd have ASS, and that would not work. All right. I like to leave this one together because it is the same thing. It's not overlapping. It's just touching up against each other. So in this one, notice we weren't actually given any information, sort of. So we're not actually given the information, but we are. So we have the markings that AC is congruent to DB, sorry. Okay. And we're given that angle ABC and angle DCB are right angles. These are from the markings. Okay. And that's all given. Then we come in and say BC is congruent to itself by the reflexive property. All right. And then we have a right triangle. We have a hypotenuse. We have a leg. And now we can say triangle ABC is congruent to triangle DCB, not R, by HL, hypotenuse and leg. And that's it.